So we're going to look at a density problem. Now, relating density to intensive versus extensive properties, let's look at the density property itself. So density is a measurement of a particular substance. So the density of substances vary. Now, density is an intensive property. So how do I know that density is an intensive property? Well, what intensive means is it means it's independent of the amount. So it doesn't matter how much you have of a particular substance, the density of that substance is going to remain the same. And if you look at a table of densities of common materials, aluminum, water, copper, etc., you are given densities of those particular substances. And the reason they can give you the density of water, for instance, so let's look at the density of water. The density of water is 1.00 gram per mil. Now that's the density of water, no matter how much water you have. So I could be talking about a drop of water, or I could be talking about an entire lake of water. It doesn't matter how much water I'm talking about, the density of water is 1, no matter what. Okay, so that's why it's an intensive property, because it is independent upon the amount. Now, what we're going to do is we're going to look at a calculation of densities, but what's different about this calculation than the other calculations that we've looked at is the units. Okay, so notice in this question, we are given the density of salt water. Okay, so it's salt water, so the fact that it has salt dissolved in it, it's not going to be 1.00, it's going to be a little bit different. All right, but the units on the density are grams per liter. And all the other examples that we've looked at, the units have either been grams per milliliter or grams per centimeter cubed. So let's look at how we would approach this problem. Let's start by just figuring out what the question's asking and what information we have. So it's asking what will be the mass, so that's our question mark. Gives us 2.10 times 10 to the negative 2 liters. So it's giving us volume, so I know it's volume because of the liters, but it's giving it to us in scientific notation. So I'm going to go ahead and write this down as my volume. It's also giving us the density, 1029 grams per liter. And we said mass is what it's asking for. So I can use my density triangle to figure out what that equation is going to look like. So mass is what I'm solving for, so I cover up the m, and it tells me that I'm going to multiply density times volume to figure out what the mass is. Before I plug these values in, I need to make sure the units are okay. So the reason I wanted to do one like this is because a lot of times we'll see liters and we'll say, oh no, we need to convert that to milliliters to solve the problem. Not necessarily. What's important is that the units are the same, and they are, so there's no conversion necessary. We have our volume in liters, and our density, since it's given in grams per liter, liters and liters will cancel, so no changes are needed. We can just plug those in exactly how they are. So I'm going to put my density first, 1029 grams per liter, multiply that by my volume, 2.10 times 10 to the negative 2 liters. Liters, liters, opposite side of that horizontal line. So 1029 times 1. I get 21.6. Let me write all the digits. 21.609, because we need to figure out how many significant figures. So you always want to look at your original numbers. So we got 1, 2, 3 sig figs here, because that 0 counts. 1, 2, 3, 4 sig figs there. Pick the smaller, so we want 3 in our answer. So 1, 2, 3, look at the number next to it. That's going to stay a 6. And the units on it, notice liters canceled, so grams are all that's left. So that volume of salt water is going to weigh 21.6 grams. So when you're doing problems like this, don't initially think, oh, I need to convert to what I'm used to seeing it in. You need to really just look and see, okay, can I cancel out the units I don't want and keep the units I do? That's the end goal.